Right, last question on the paper. It's an asterisk question and it's a circle theorem. Worth 3 marks, so we need to be doing 3 things of note. And on this picture here, it's asking us to prove that the triangle ABD, which is this one, is congruent to triangle DCA. Okay, congruent is one of those fancy mathematical words to basically say that they're the same size and the same shape. So we need to do a few things here to work this out. We need to start proving some different aspects. The first thing to note is that on both triangles they share the length AD. You can see it's the base of that triangle as well as the base of that one. So both share side AD. Alright, that might get me a mark. We'll find out in a moment. Alright, what else can we do? Well, I'm looking at the shape here and I can see what might be described as a bow tie pattern. Now, that is useful. However, writing bow tie down as a circle theorem is not going to get you anywhere successful. So we recognise it's a bow tie and that this angle and this angle are the same. Now we need to write that down. I'm kind of showing it on the board, on the picture that they're the same. However, I would need to write it that angle, and this angle will be described as angle ABD. When you're writing 3 letters together, it's the middle letter where the angle is located. It's pointing from A towards D. Angle ABD equals angle A, going up to C, down to D, angle ACD, and I haven't written angle there, but you can sometimes do it with a hat to show it's an angle. So either which way, normally I'd use the same thing. Angle ABD equals ACD. So I've said it, I've now got to say why, because, and this is where I can't write bow tie theorem down, but because angles in the same segment are equal. Alright, so we've got another fact there. So we have 1, we've now got 2, and we've given an explanation to that second one, which is definitely going to be worth a mark. Now I'm looking at both of them. I can spot another thing. We're told that O is the centre of the circle, which is quite important because it then tells us that AC, going from either side of the circle passing through the centre, is the same as BD. So the hypotenuse of both triangles are also equal. So AC is equal to BD, as both are diameters. Alright, so we've proven that the triangles share something else in common. There's another aspect I can also do to show that they're common, and that's the bottom corners of both, which is hard to explain, but the ACD, I mean this bottom corner here, this is the one that's located at D, and likewise the one that's located at A here. We've got another circle theorem we can use here, and that in this semicircle here, when you've got 2 chords that go from a diameter to another point, this is going to be 90 degrees. So this angle will be 90 degrees, and this one will also be 90 degrees. So we've also got that angle BAD is equivalent to angle BAD, which one are we at now? ADC, as both are right angles. Something along the lines as angles in a semicircle are 90 degrees basically. Right, so we've proven loads of things are the same, which is quite important for congruent triangles. So we've got 2 angles the same, and we've got 2 sides that are the same. Now with the 2 angles that are the same, there's 3 angles in the triangle, and if 2 of them are the same, the third one must be the same. So all angles are the same for both triangles. Now that's not good enough at the moment. Are the same for both triangles. We now also, the fact that angles are the same, we've also proven twice actually that the sides are also equal, and that means that the triangles are both congruent. So if the angles are the same and you've got a side that's the same, that's one of the reasons we can use to show that they're congruent. All angles are the same for both triangles, and as they share 2 equal sides, maybe not the best language used here, but as they share two equal sides, the triangles must be congruent. Alright, you'll probably be able to word that better than myself on that last bit, but if we've proven that all the angles are the same and we've got at least one side that's the same, the corresponding side, and if two of them equal, the third's going to be the same, they're basically the same size triangle.